So, it all starts with a pizza. Making bol.com better is like making the best pizza. So say we want to make the best pizza, best-selling pizza everyone loves. Our first approach is to start by adding the best ingredients and use A/B testing on our customers. We start with, for example, adding a subscription option for appreciating loyal customers. We are making Billy better to being able to handle service requests faster and test different models against each other. And we can add some changes in the look of our user interfaces to persuade customers and create better recommendations. And we can start a lot of A/B tests to make our webshop even better. And at a certain point, it looks like the picture on the right? So we added a lot of persuasion methods. In this case, it was an April Fool's joke. But it's a good example what can happen if you only focus on the short-term gains by adding in persuasion methods and extra features and do not care about the longer-term performance and complexity of your product. So the main thing I want to tell you is that adding good ingredients to a pizza doesn't make it the best pizza. Just like adding the best ideas to a product doesn't make it the best product. So a quick recap to how A/B testing works. The goal here is to measure the difference in the metric between two or more alternatives. We compare a new solution to a control group, which is usually an existing or an alternative solution. We measure the statistical significance, which tells us whether a change is likely real or due to some random chance. So how can we optimize something? First, you need a KPI, something you need to optimize for. This can be a metric for revenue, profit, or conversion rates, click-through rates, engagement scores, or it could be a reduction in customer service cases, or customer service satisfaction scores, or any combination or any other metric that we can think of. You also need a few parameters you can change in order to optimize the KPI. It can be things you believe are important, like whether you show something at a certain moment and in what order you show it. Maybe you can change the size of the text or change the color of a button. But you can also test different algorithms and models and settings or something completely different. So, I think A/B testing is really a great tool and you should definitely use it if you don't. So, what is exactly wrong about it? In A/B testing, we only focus on a very small subset, a few alternatives to make it practical. However, one big downside of this is that we only test a relatively small number of alternatives, and we constrain the search space way too much. In order to improve, we should do much more exploration so we can come to other and better solutions. Also, because we are running A/B testing splits for longer times, like 2 weeks or 4 weeks, we can lose a lot of money in the meantime. A/B testing does not, or manual A/B testing does not take into account intermediate results, so it doesn't exploit the knowledge you can gain while running an A/B test. Another downside of A/B testing is that A/B test usually stops after the testing period ends. This means that when a variation stops being beneficial because of other changes in your website or in your product, we'll still keep pushing a worse version to our customers. So who says that your change is still positive next year? Finally, A/B testing can be very time-consuming. To set up an experiment often requires planning and lots of manual steps and persons are involved. This quickly grows whenever you want to run more and more tests and more alternatives on your website. So let me introduce an alternative, different solution, which is called Blackbox Optimization. It optimizes a function which we don't know the shape of. By sampling this function, we can either maximize or minimize the expected outcome, which is called optimization. The nice thing about this is that we have a lot of algorithms available that are known to work well, like Bayesian Optimization, bandit algorithms, evolutionary algorithms, and more. So what can we do with this? We, for example, can automate A/B testing and make optimization in software much more impactful. We can also automate the design of algorithms and find hyperparameters and make models we learn much better. And we can also apply these techniques into domains like conversational AI, robotics, and self-driving cars. So I want to show you a few algorithms that can are black box optimization algorithms. So a Gaussian process is a good example of a black box optimization algorithm. And the idea here is that of uncertainty. So if we sample points, there's some uncertainty to what information it gives. Points close to each other are in many functions also similar, which is a property we would like to use. Using the acquisition function here on the right, we sample the new points, and we pick the most interesting points, most promising points that there are to sample. Evolutionary methods also can optimize black box functions. Evolution works by randomly changing parameters within a population and by selecting the best members of a population at each optimization step according to a fitness function. CMA-ES is a smarter version of an evolutionary algorithm that changes the distribution while optimizing, so it will more quickly converge to an optimal solution. So in this animation, you see it stretching towards the optimal spot on the left side. A nice way to use black box optimization or Bayesian optimization is for optimizing machine learning models. Here you can see it being used for optimizing the parameters of a model and hyperparameters. It tries to get a high score for both validation accuracy while having a low inference time. So it becomes both fast and accurate. And you can clearly see the Bayesian approach in the blue, and it optimizes to a much better model with a much better trade-off. Tech companies like Google started to think about how can they make it easier to use these algorithms and such a system for optimizing any product, any software product. The idea here is to use a centralized service with an easy-to-use API which can be used from multiple services. This service contains many tuned algorithms and contains dashboards to get insights. And it can be used in a distributed environment. So if you want to start using black box optimization in your service or in your domain, there are lots of different alternatives. Some more focused on A/B testing and other more focused on machine learning. So the most well-known is one from Google called Google Vizier. But it's also being integrated into AI platform for machine learning. There's Katib, which is part of Kubeflow, a system for designing machine learning pipelines and modeling, setting up machine learning jobs, training jobs, etc. I also made a clone of Google Vizier written in Rust called Sweet Spot. And there are some others by Microsoft. There's a company called SigOpt, which focuses on this domain. And Advisor and Metric Optimization Engine are some other alternatives. So I will show you a quick demo how a Gaussian process exactly works. So basically what you see here on the here above is that at this moment we didn't sample any point at all, but there is an underlying function which is randomly being generated, but we don't know yet this function. And this green part is basically the uncertainty around this function. And we assume that this function is centered around 0. There are some other parameters, like the variance of the algorithm, which says something about this uncertainty. So this green part. And also the length of the scale, which we will see later. And some other parts, how to optimize the expected improvement function, the acquisition function. But this function basically doesn't know anything because we didn't sample anything. Well, by adding a point, we will see, well, we now know a bit more about this function. So we got this result here, but there's some noise, some uncertainty around this point also. And this expected improvement function thinks it looks like this. And what we do now is maximize a value, this value for this function. So the next point we will sample is around 0.6. And now we know more and more about this function, how it will look like. And we also think it is better to look at the right. And we quickly will see that the algorithm sees that here right at the right below there's some minimum. So it starts to sample much more in this area than in other areas until a certain moment, and this part will win again. So this is how this algorithm works. So earlier we said we can also use optimization for optimizing machine learning models. Here's how that works. We create a study with a setup of the parameters and the metric we like to optimize. And we repeat until we are satisfied. We train a model until we, with the suggested hyperparameters, and report the evaluation metric value. And this is being repeated, and we get new suggested parameters. So now I will tell a bit about HyperTune, which is the service integrated into AI platform by Google. It performs Bayesian optimization, and it's really simple to set up and use. And I will show you how you can set it up. Is that a bit readable? Yeah, I think so. So here the goal is we set it up with a configuration file, and we say, well, we basically want to maximize the metric values. And we say, oh, this metric tag, the name of the metric is in this case called ACC, short for accuracy. And we set up a parameter budget. So in this case, we say we want to maximum 100 times try and train a new model. And we also say, oh, we want to run maximum 2 parallel trials at the same time. So why is this? The more parallel trials you start, the less information you get at each sequence. So the lower you set this number, the cheaper this process will be, but the slower. And the higher you set it, the better this will be, but the faster this will be, but much worse. You get worse results. And we set a few parameters and parameter configs. So we can set, for example, we want to tune our learning rate of the model, and we say, this is a double value with a certain minimum, certain maximum, and we say something about the scale we would like to use. And we want to also optimize, in this case, the embedding size, something in a model which we would like to change and makes the model either smaller or bigger. After this, we have to use these values in our model. So we first, AI platform or this within AI platform, we have to use these values. For example, the learning rate, we process it and get it into our code, and the embedding size. And we also need to have the directory where our job runs to be available. And then we have to set up our model with these hyperparameters. So you see it being used here in the embedding layer, where we set up the embedding size, and lower here we use the learning rate, which is given by the algorithm. And after this, we report the metric to the algorithm, which basically means writing the accuracy to a certain directory, certain file, and certain format. And after this, we just have to wait. So it starts trading and submitting results to this algorithm, and start again and again trading new models. So here you see it being generating different models with different different hyperparameters and different accuracies. And I also did some experiment last week on one of our own intent recognition models, where we before had a model that had 70.5% accuracy. After optimization, we get it to 73.3% accuracy on the validation set. Maybe this sounds small, but over a lot of predictions during the day, this can have a really big positive impact. Also, for future experiments, there's still room for improvement by adding much more flexibility to the model. So in this case, we use parameters like learning rate, dropout values, and number of hidden units in the layers, but we can also change the depth of a model or change the number of filters in a convolutional layer, etc., to make the model much more flexible, and then there's much more to optimize for. So in conclusion, we can and should do much more than manual A/B testing. There are many suitable optimization algorithms available, which we can use. The ecosystem is growing, but currently there's no one-size-fits-all solution yet for public or open source use. And there's an easy-to-use solution within AI platform for optimizing machine learning models. So, this was my talk. Do you have a few questions? Yes.
I was wondering, how does this translate to bol.com in practice? Like, how would you use this in a case?
Yeah, for example, most A/B testing setups we can actually change to this paradigm. So what you can do is instead of waiting for 4 weeks, we can automatically tune A/B testing setups with an algorithm, and in that way you can save a lot of money during the A/B test itself already. So for experiments that contribute a lot of value, this can actually save a lot of money during this system. Also for machine learning, optimizing machine learning models, there's a lot of room. And I think also for combining different setups, letting them keep running, is also an interesting use case within bol.com. And I think also we can be much more flexible in A/B testing than just testing 2 or a few variants, but making it more flexible by just being able to change almost everything.
Thank you.
Nice. Hey, Daniel, great presentation, thanks. I'm a bit hesitant on replacing A/B testing with this optimization, though, because like A/B testing tests our assumptions on real-world usage of users, and this seems like you can only optimize into metrics where you already know what better is. So how can you replace an A/B test that validates actual usage with this?
Yeah, great question. I think you should also only add optimization to such a system, because the goal here is different. With optimization, we would like to find a good setting of parameters which works good and doesn't cost us too much money. With A/B testing, you want to actually scientifically verify whether the change in parameters or change in versions is actually different than another version. So I think even if you optimize websites or software with this product, at some point you would also like to, for example, compare it with the older version which is not optimized, and then you can just run it, still run it against each other and see whether this new optimized solution is really better, or it just found some other parameters which really didn't help anyway.
Yeah, cool. That makes sense. Thanks.
How would you go about, like, how would it influence your black box? We're thinking if it takes a long time for the KPIs to be calculated. For example, one of your ideas was like you can, when you're A/B testing, one of your KPIs can, for example, be amount of customer service calls from a customer. So if you have to wait for a month after a purchase to see whether a customer has called, how does that affect it?
Yes, this indeed is one of the complications for this approach. So ideally you want to have the metrics more quickly available, which is the case for click-through rates or some engagement scores or checkout process or metrics. For customer service cases, this is usually, for example, within a day, you can keep that. So you need to make the process a lot slower, actually, if you have also much slower processes. That's the thing you have. There's it's more limited if your process is also very slow and you don't get a lot of metrics during the optimization. Yeah.
No more questions? Oh, I see one more.
All right. Yeah. So, how do you set the range of the parameters? Like just intuition, or is there like methods to know if you've done it wrong? If there's better values outside of the range that you've given?
Yeah. Mostly, yeah, it's intuition. So it really depends on your domain and your assumptions you have about your function or your metrics and the parameters you want to optimize for. So setting a good range in those values can actually help a lot to get it more quickly evaluating to a good parameter setting.
Okay. Yeah, cool. Okay.
I think that was it.
That's it. Then I would like to thank you.